Have you ever wondered how your smartphone, laptop, or even electric cars store and release energy so quickly? The answer often lies in a small but powerful component called a capacitor. A capacitor is an electromechanical and electrical device that stores energy in the form of an electric field and releases it when needed. It plays a crucial role in almost every electronic device around us. Structure and construction. At its core, a capacitor consists of two conductive plates separated by an insulating material called a dielectric. The dielectric can be made from various materials such as ceramic, plastic, paper, mica, or electrolytic solutions depending on the type and purpose of the capacitor. When a voltage is applied across the plates, positive and negative charges accumulate on the opposite plates, creating an electric field. This storage of energy makes capacitors essential for regulating voltage and smoothing out electrical signals. The physical construction of capacitors varies depending on their application. Ceramic capacitors. Small, non-polarized, often used in high-frequency circuits. 15155 electrolytic capacitors. Larger, polarized, used in power supply circuits for filtering and energy storage. Film capacitors. Use plastic films as dielectric, known for stability and long life. Supercapacitors. Ultracapacitors store extremely large amounts of energy, bridging the gap between batteries and traditional capacitors. Applications in everyday life. Capacitors are everywhere. In your smartphones, they smooth out power fluctuations and support the camera flash. In computers and TVs, they stabilize voltage and filter noise. In electric vehicles, supercapacitors provide quick bursts of energy for acceleration or regenerative braking. They are also vital in industrial electronics, including motor starters, signal processing, and energy storage systems. Other practical uses include timing circuits. Capacitors control the timing in oscillators and clocks. Power factor correction. In large industrial machines, capacitors help reduce energy loss. Energy storage. Capacitors provide rapid energy release in applications like defibrillators and camera flashes. Filtering and smoothing. In power supplies, capacitors smooth out voltage fluctuations to protect sensitive electronics. Role and importance. The key role of a capacitor is energy storage and release, which allows devices to respond instantly to electrical demands. Its construction, especially the choice of dielectric material and plate arrangement, determines its capacitance, voltage tolerance, and suitability for different applications. For example, ceramic canators are ideal for less than mA/Fren, whereas electrolytic capacitors handle large energy storage in DC circuits. Supercapacitors push the limits further, storing hundreds to thousands of times more energy than standard capacitors of similar size. By understanding the structure and function of capacitors, engineers and hobbyists can design efficient circuits, improve energy management, and enhance device reliability. This tiny component, often overlooked, is at the heart of modern electronics. Conclusion. Capacitors, though small, are powerhouses of energy management. From storing and releasing energy to smoothing voltage and filtering noise, they are indispensable in both.